Hey everybody, this is General James.
And his mom.
Today we are going to be doing Apologia Astronomy, Lesson 2, Activity 12, the temperature of the rainbow.
Did you know that the energy coming from the sun has much more than just the colors of the rainbow in it? You are going to do several activities to understand not only the visible rainbow, but also even more of what is found in the sun's light. In this image of the electromagnetic spectrum, you can see that the rainbow of colors makes up only a very small part of the light coming from the sun. Let's explore all aspects of these fascinating facts. Do you use a microwave, a radio, a cell phone, or even television? These objects use at least one form of electromagnetic waves. Man-made objects use electromagnetic waves to function, but the sun and other objects in the universe also emit electromagnetic radiation. To better understand the electromagnetic spectrum, we will first define electromagnetic radiation. Let's start with electromagnetic. Electromagnetic is another word for light. Stars, planets, and the sun all have magnetic fields. In fact, all objects with a temperature above absolute zero, which is the temperature where atoms stop moving, radiate electromagnetic radiation. Look again at the electromagnetic spectrum illustration. Find the visible light section. This is the part of the electromagnetic spectrum that we can see using our unaided eyes. When you look at the illustration, you will see that we can only use our eyes to detect very little of the entire electromagnetic spectrum. That does not mean that it does not exist. Remember that the light from the sun looks invisible to us until we split it out into its colors. Sometimes you might hear the term white light instead of visible light. The light we see with our eyes does have color, but we cannot see the colors until we view the rainbow in the sky or we direct the light through a prism. Look at the image of the prism. The visible white light enters the prism from the left. The prism then splits the white light into its wavelengths of different colors. Each individual wavelength within the spectrum of visible light wavelengths is representative of a particular color. You may already know the mnemonic phrase, Roy G. Biv, to help remember the color and order of the waves in the visible light spectrum. Red, R, orange, O, yellow, Y, green, G, blue, B, indigo, I, and violet, V. When light of that particular wavelength strikes the retina of our eye, we perceive that specific color. When all of the colors strike our retina at the same time, we perceive white. Thus the name white light. Did you know that individual colors have unique temperatures associated with them? In 1800, William Herschel devised this experiment to record the temperature of the different colors in the sun's light. His experiment also led to the discovery of infrared waves. In this first activity, you will see the colors in the visible light spectrum and chart their temperatures. You will also chart the temperature of the infrared light that you cannot see.
In this experiment, you will need your rainbow maker, which we have right here, a thermometer right here, some white paper we got right here, clear sunny day, we got a clear sunny day, and a timer. Okay, so what you will need to do is you will need to place your rainbow maker in direct sunlight so that it creates a rainbow on the white paper, which we have done. So then we'll keep our thermometer out of direct sunlight for 10 minutes and then note the temperature here.
Let me go grab the thermometer.
Okay. Okay, so the temperature we recorded in the house was 74 degrees Fahrenheit. So then what we did is we brought it all out here in the great outdoors and then So we put the thermometer in the yellow part of the rainbow. So then I'm going to start the timer now for 10 minutes. Okay, so we put the thermometer in the yellow part of the rainbow. So then we're now going to record the temperature of it.
So go ahead, you can lift it up. Don't touch the red part and figure out exactly what it is.
It is 90, exactly 5.
Okay, so then we're going to record it in the yellow section. So go ahead and write 95. Perfect. Okay. So now, Jimmy, what's the next step?
So next, we're going to keep the thermometer out of direct sunlight for 10 minutes and then note the temperature right here on this sheet. Okay, so we let the thermometer sit out of direct sunlight for 10 minutes and the temperature was 74 Fahrenheit. So then now what we did is we put the thermometer in the violet part of the rainbow. So we're once again going to let it sit here for 10 minutes and then we'll record the temperature. So I'm going to start the timer now. Okay, hello. So we let the thermometer sit in the purple area of the rainbow for approximately 10 minutes. So then I'm going to grab this and then let's see what temperature it's at. It is at 86. 86 degrees Fahrenheit. Okay. So then, now we're gonna let it sit out of the direct sunlight for 10 minutes and then we'll be back when that happens. Okay, so we left the thermometer in the house for 10 more minutes, and the temperature was 76 Fahrenheit. So then now what we did is we put the thermometer in the red part of the rainbow. We're going to leave it in here for 10 minutes, and just started the timer. And then, yeah, we'll come back in 10 minutes. Okay. So we have 10 more seconds till it's over. We let the thermometer sit in the sun on the red part of the rainbow for 9 minutes 57 seconds now, and it's about to be exactly 10 minutes. So
Record
now,
the temperature.
So we're now going to see what the temperature is. It is 95. It's around 95. It's kind of hard to tell on this little thing. Okay. So now what we're going to do is we're going to let it chill back in the house for another 10 minutes, and we'll see you back in 10 minutes. Okay, so we left the thermometer in the house for 10 more minutes, and it was 75 degrees Fahrenheit. So then we came back out here, and then we moved the thermometer slightly closer to the rainbow maker. So then, and this is in the infrared range. So then we're gonna let this sit here for 10 more minutes, and then in 10 minutes we'll come back and look at the temperature, and then we have a quick little discussion, then the video will be over. Okay, so 10 minutes are up. So we left it in the thermometer in the infrared part of the rainbow. So now I'm gonna grab this and let's look at the temperature. It is 86. I'd say it's around 86. Okay. 86 degrees Fahrenheit is what I'd say our temperature is.
All right, Jim, so we have all of our
Readings.
Let me get a camera shot of that. So the yellow findings were 95 degrees, the violet findings were 86 degrees, the red findings were 95 degrees, and the infrared was 86 degrees. All right, now on to the discussion. The first activity is designed to show an increase in temperature from violet to red. Our measurements relatively agreed with the above statement. Our violet measurement was 86 degrees Fahrenheit and our red was 95 degrees Fahrenheit. So that definitely showed the increase in temperature from violet to red. However, our yellow was also 95 degrees. Possible sources of error. It was challenging to differentiate a degree or two on the thermometers that we used for this experiment. There were also a lot of clouds in the sky, and guaranteeing an exact 10 minutes worth of sunshine was difficult. For the second experiment, Herschel noticed an even warmer temperature measurement just beyond the red end of the visible spectrum. He had discovered infrared light. Our measurement was not in agreement with the above statement. We expected the answer to be higher, but it definitely was not. Our infrared light temperature, we read, was 86 degrees Fahrenheit. Again, some potential source of error. It was difficult to know if we were in the infrared range of the spectrum, because as we've learned, infrared is not in the range of wavelengths that our eyes can see. And most probably we were not in the infrared range. And there were also clouds in the sky.